Hey guys, hope you guys are all well. So in our last video, we went over a brute force implementation of leftmost column index of 1. In this case, let's go over a slightly optimized version of that where we use binary search. So let's jump right into it. All right, so just kind of revisiting the question. So I have it copy and pasted here. So we're given a binary matrix where all elements are 0 and 1. And remember, a matrix is essentially a 2D array, so it's an array of arrays. So in this binary matrix, every row is sorted in ascending order, 0 to the left of 1. What we want to do is find the leftmost column index with a 1 in it. So what do we mean by column in this case? So in a matrix, the column is essentially you know how a matrix is an array of arrays. For each individual inner array, that's considered a column. So why is that considered a column? Well, because let's say we're given a 2D array / matrix, right? Like in this case, the question is asking us to look at the leftmost column. So you can kind of visualize this with the rows stacked on top of each other. And it's better this way because you can then kind of see what is meant by a column in this case. So in this case, I kind of rearranged things where the rows are stacked on top of each other. So you can see that we're looking for the leftmost column that contains a 1 in it. So we kind of visually, you're kind of scanning from left to right each column. So in this case, it's a special case. We want to return -1 because this is what we can just define in the problem. Like if there is no 1 in the matrix, then we return -1. But in this case here, let me stack everything up. Right, so stack everything up. Okay, so again, scanning from left to right, left column to right column. The first column contains all zeros, right? So we don't return anything. But the second column has a 1 in this third row here. So because the second column is the first column that we've encountered that contains a 1, we return the index of this column. And remember how I said earlier, the index of a column is essentially for an inner array, which is it's a row. So an inner array is a row. We return the index of it. So in this case, the inner, because it's a rectangle, all the inner arrays have the same length. So the first index is that we see at 1 is index 1 in this row here, right? So we return 1 as the output. All right, so let's think about how we're going to approach this problem. So in our last video, in a worst case scenario, we visited each element in the matrix, right? So the time complexity wise was not ideal because we had to visit each element. So you can imagine that if the matrix is huge, you gotta see every element, and that kind of hurts our time complexity. And usually in LeetCode, if the solution is O of n, where n is a number of elements in the matrix, again, depending on the question, but usually in that case, it's not the most optimal solution. So let's look for an improvement here. So one thing that's very important in this question is that we know that each row is sorted in ascending order. And quick note about this, I think I've seen this question where they say, instead of saying each row is sorted in ascending order, they say each row, the zeros come before the 1. So it's a bit of a way to kind of, I guess, trick you up into not thinking that each row is sorted. But just be aware of that. So that's something you might see. So anyways, but we know, like, given the problem in this case, that each row is sorted. So whenever a row is sorted, one immediate thing that should come up is, boom, binary search, right? So, and this is now going back to another one of my previous videos, which I will link in the comment or in the description box below, is what if we, for a given row, could use binary search to search for the first position of 1, right? So in our last video, or not last video, but one of my previous videos, we binary search for the first occurrence of a certain target number. So in this case, we only have zeros and ones in the entire matrix. So what if we search for just the target element of 1, right? If we could binary search that, find the position, then for each row, we will know the position of the first occurrence of 1. And that's essentially the first column where 1 takes place and shows up in each row. And then out of all those positions, again, we're iterating through the rows, right? We can then just find the smallest one, right? So that's basically the idea. It's pretty straightforward, I guess, once you know that, okay, we can use binary search. And remember, binary search is a drastic improvement over like a linear search where you have to see every element, because in binary search you're repeatedly cutting the array in half, right? So it becomes login complexity. In terms of why it's login, I won't go over it in this video, but login is a drastic improvement over linear time. So let's get into how we can implement this. All right, so let's maybe start with like a high-level approach. And I think this in general is a good I might mention this again in all my videos, but I think it's an important point to start with a high-level approach first, just to get the algorithm down, and then to fill in details. Because some people have a tendency to, start coding immediately before even going over a high-level approach, and then they might get caught up in the details when the details maybe don't matter as much, because sometimes the interviewer will help you do like the smaller details. So start off with a high-level approach. So let's do that here. So high-level approach. All right, so basically, like I just mentioned, what we're going to do is, let me move my big face out of the way, down here. What we're going to do is, for each row, right, so this you can imagine is going to be some kind of loop. For each row, we are going to binary find the first occurrence, can't spell, of 1 using binary search, right? And, all right, say we have that index, right? So we have some kind of like index, right? Let's call it call index, right? Because we are finding the leftmost column, right? So say we have the call index for each given row, right? And this is, how do we find the global minimum then, like out of all the rows, right? Well, in order to do that, remember like little, I wouldn't say a trick, but sometimes not as obvious, is as you're iterating through each row, compare the column index of that row with some kind of global minimum, right? Because in that case, when you compare those two numbers, you take the smaller and you set it to a global minimum. At the very end of all your row comparisons, you're guaranteed the minimum, right? So if that's not too clear, like take a pause the video and think about that. Basically, you're at each given comparison. So I'm going to show you here what I'm talking about. It might be a little easier. So let's call it result minimum, right? Let's initialize it initially to some like high number, right? Some high number. Remember, this is still a high-level approach, so we can fill in details later. So the result minimum is basically the result of is going to be result of taking the minimum of itself. Remember, you're setting it to itself, right? With the call index, right? So again, so what you're doing is you start off with some result minimum, some high number, and then so you start iterating. And say for the first row, you find the first occurrence of 1, right? And what you do is compare the first occurrence of 1, that call index, with the result minimum. And then so what's going to happen is it's going to return a call index because it's guaranteed to be smaller than a result minimum, because remember we set some super high number. And then that's going to set the new result minimum to the result of the row search that we did with binary search, right? So you can imagine, we do that again and again for each row. Doesn't it make sense that at the end of your iterations, after you're done checking each row, it's going to return the global minimum, right? So what you do down here is return the result minimum, right? So, okay, so we can probably start implementing this. Because this is pretty much it, I know there's some details we need to fill out. For example, what if there are no zeros? We probably have to do some kind of loop, some kind of conditional here to check, that we did not find a 1, right? Or yeah, that we did not find a 1. So that's not that big a deal. So let's just start with this maybe. So I'm gonna start writing the implementation down here, right? So basically, let's call it define leftmost 1, right? It's given a matrix, and we're going to iterate through the rows first. So for I in range length matrix, right? Because each row is the inner array, right? So you can imagine, I think we talked about this last video, but again, good to emphasize, each row here corresponds to something like this, right? B, whoops, C, let me format it better, I'll know what I'm talking about. C, D, right, oops, get rid of that. So A is the first row, B is the second row, so on and so forth. So basically this is all to say that your outer iteration here is iterating through A, B, C, and D, right? And A, B, and C, and D are the rows. So what I'm going to do here, just to be really explicit, row is matrix of I, right? All right, so now we have the row. For each row, so we have a row, we find the first occurrence of 1 using binary search. So let's, in this case, we have to implement binary search. So whenever you think, okay, we have to implement something kind of that's, maybe it'll take more than a few lines and might get a little cluttered. If you get that sense, then extract it out to a function. So let's say it's to perform binary search. You can always, naming's always like, you can change it later. But let's just start with this, perform binary search over the row, or find first occurrence even. That's probably better, using binary search here. Okay. So call index is equal to this, right? I'm just like kind of copying here what we're doing. So, and then we have a result minimum. So this is where we start to fill out the details, right? So remember, we want to set result minimum to some high number. So what do we want to start off setting it at, right? Because remember, if you set result minimum to -1, some people might have a tendency to want to do that just because we define the case where there are no ones, where it's all zeros, to return -1. So for whatever reason that people might be kind of stressed out and not have they might not be thinking too clearly. They might just set -1 and kind of like a panic state. But in this case, and again, you'll get used to this through practice, we are finding the minimum of 2 results, right? The result minimum and the column index of the first occurrence of 1. So in that first time that we iterate through this matrix, when we check the first row, we want to guarantee that we're setting the result minimum, right? So if we set it to -1, it's not going to set result minimum to the first occurrence, right? So you can imagine here, we see row 1, or first row, and the first occurrence is going to be at 0, 1, 2, 3, index 3, right? But if result minimum is -1, -1 is already less than 3, so we're not going to set call index to 3, right? So let's set it to something big, like a big number that's probably out of bounds. What I mean by out of bounds is it's going to be like the index right here, the index after the last biggest possible column index. So each array is of size length of matrix. Oh, sorry. Each row is size length of matrix 0. So what if we set it to that? So maybe it's better if I write it out. You guys can see length matrix 0, right? Because this is what I'm highlighting here is the row. So if we set the length of the row, we are going to be given the index that is 1 greater than the actual within bounds index, right? So that way we're guaranteed to set this. And if we do that, we should be able to then do this comparison and be guaranteed, again, to be set. So let's do that, right? And at the end, let's just for now, we do result minimum. Okay, so now we can kind of think about what happens if it's all zeros, right? Well, what happens if it's all zeros? If it's all zeros, then you can kind of think, what is this going to return? Because this is kind of dictate what we do in a case that's all zero. So interesting. Actually, maybe in this case even, let's return, when we do the binary search for each row, if the row has all zeros. Again, we're going over the case where it's all zeros. So if each row has all zeros, that means we need to find out what to return, and let's return, just to be consistent, this, the length of the row, right? Because in that case, we get it passed back to this layer here. And what I mean layer is that when we call this function, we're going to go in like an inner layer, right? Some other function call. But once we call this function, it returns a call index. Let's say it returns length in matrix. When we do the minimum comparison, the result minimum is going to be the length of the matrix at the length of the row, right? So at the end, that means we can kind of use this like consistent methodology of the length of the row to determine what to return. Because if we adhere to the fact that all zeros means we return the length of the row, down here we can use that as an indicator that it has all zeros. So basically what I mean is, if the result minimum is the length of the row, aka is length matrix 0, then that means we found no ones. So we return -1 in this case, right? And else, we could write else here, or we could just, do return, because this is essentially will break us out of this function here and prevent us from calling anything else below that. So, so just keep it simple and a little bit easier to read, I suppose. I'm going to avoid using the else statement. So yeah, this should be it. So all that's left for us to do is implement this function. So I'll do that here as a helper function. All right, so I'm have that previous video linked where we find the first occurrence of a target element in a row. So I'm just gonna kind of breeze through this part. So I'm just gonna code it out. Let's see if I can code it out without thinking too much into it. Or so we need a start index 0. So you can either follow me here and kind of like rewind if you want, or you can just kind of use view that last video. Start index here. Well, start index less than an index. Let's go ahead and I think it's less than or equal to. Let's go find a mid. IDX is start index plus end index divided by 2, right? So remember, if the middle element, which is row mid IDX, is equal to, remember, we only have zeros and ones, so we don't have to worry about any other numbers. So let's say if it's 1, then we want to set the end index equal to mid IDX, because that could be where, because the mid index could be where the first occurrence exists, right? Else is basically saying 0. We want to search the top part of the array, so we want to set start index equal to mid index plus 1, and ultimately we want to return the start index here. Okay, and why this is, again, recommend going back to that other video I linked in the description box and kind of going over that. So actually, just to make sure that this works, I'm not gonna copy and paste what I did, but let's run a few test cases. And this will be a good exercise or a good visual for you to demonstration. I said visual for you to unit test, right? So if you have a helper function, I'll recommend testing that helper function out first, because yeah, we could probably run this whole function with against like a sample input, but if there's a bug, it's going to be a little harder to find just because it calls and goes through so much code. So let's test each helper. Let's test the helper function first. So what I'm going to do here is, let's say, print this given a row, and we'll pass it a row. Row here is 0, 0, 1. This result, expected result is going to be 0, 1, 2. Right. Equal to result. We'll do the same thing. Oops. We'll do the same thing down here. 0. Let's do something like a little fancier, I suppose. Let's call it result 0. And oh yeah, this is, I think we missed. And this is why like building test cases is good, because you'll start to realize, oh, I forgot the case. So one case I forgot about is the case where there's only zeros in a row. So in that case, let me think, how is this going to work? Oh, we might need to modify this a little bit, because if there are no zeros, oof. So you can imagine if there are no zeros in this case, start index is, so let's think about like this. What if we have all zeros? What if all zeros in the row, right? So if that's the case, like something like this, 0, 0, you can imagine, let's make it a little bigger. You can imagine as we search this, just by our binary search, it's going to take us all the way to the last index, right? So I think what we can do, actually, let's just, to be safe, let's think about, let's just use this as a simple example. Row 0, let's say we're going through the row is 0 case, right? Row only contains the element 0, start index is 0, end index is 0, mid IDX. So that means mid IDX is also going to be 0. So if row mid IDX is 1, which is not, else start index is mid index plus 1. Okay, so that should work, because we're going to hit this part of the loop and start index is going to go 1. So it's going to give us what we want here. Okay, so we actually don't need to worry about any like other conditional, we don't need to make any adjustments to the helper function to account for the all zeros case. Okay, so let's go ahead and run this. Let's make sure this helper method works again. Python, I think, yeah, Python main.go. Might need a CD into my documents file. Cool. Oh, Python. Lovely. True. Awesome. All right. So this helper function works. So that gives us some kind of confidence that, all right, maybe we can start running the larger function now. So let's start doing that. So that way, if this fails, that means we know it was some part of the code that is not the helper function. So we can kind of rule that out. All right. So let's actually start like building some cases, and I think we can actually just use these here. And so we're gonna do the same thing as we did below, or just previously. So let's do matrix and make this explicit, results -1. Let's do print. Let's make it together just to be really clear. Matrix is result. Lovely. And let's do something here, down here. Sorry, this part's a little boring. Matrix is blah blah, and then result here should be, I believe, 1, right? Yeah, it should be index 1. So let's do that, and let's maybe go with just one last case. Maybe the last column is all 1s and everything else is 0s. So like, sorry, it's not terribly readable, but let me clean it up. do. Oops. Oh man, if I've been coding in Go, I forgot how to like. There we go. It's like multiple lines at the same time. Super helpful functionality here, by the way. It's Command Option. That's what I set it at. Okay, so let's make this all zeros. And this should return 0, 1, 2, column 3, index. All right, let's run this fella here. Okay, clear it out. Moment of truth, some high number. Yeah, that makes no sense. I gotta comment out our notes here. No biggie. Biggie. And wow, some high number. Where did I type some high number? Did I not save this? I saved it. Anyways, let's try it again. Okay, if result minimum is line 57. These are just small errors. Like usually in LeetCode, you know, if you have the chance to run an ID or run your code, like you're gonna experience little issues like this. It's not a big deal at all. True. Oh, true. But we're hitting. See how it's not finishing running? There's definitely some kind of infinite loop going on. I'm gonna cancel out all this. So the first one worked. Very good. But this one did not work for some reason because it got caught there. But just to be sure, let's run it again. Yeah, see how it output the first one, but not the second one. It gets hung up. Okay, well, what happened then? Let's see. So in this case, interesting. Index. Just kind of revisiting this. Okay. I'm just glancing through the code just to see if I missed anything. Result minimum is this. Length of matrix 0. To be honest, the only place I can see or envision a loop is here because this has a while loop, right? So but then we already checked this helper function. So what's going on here? Let me comment this out. Let me just run. I don't know why this would matter, but we're trying. Yeah, see how it gets caught up here? Okay. Interesting. What we could do is we could run this against each of these rows, right? Because the helper function checks each row. So let me see here. This is very interesting. See if I see anything immediate. I really don't. Alright, so I'm gonna back up here. We're gonna test the helper function again against one of these rows. So something happened here. I'm gonna comment this out. So our rows are 0, 0, 0, 1. Right, let's run against each of these maybe. Oops. Rows this. Let's do. And I won't run it against an expected result. Let's just see which one of these gets hung up, you know. Blah blah 0, 0. Oops. One here. And see, a lot of this takes a lot of patience, right? You gotta kind of a lot of typing, go through each one. And last row, I think it's all zeros. It's all good. Okay. Let's see if this gives us. The first one, the very first example is caught in some kind of loop. So let me get rid of these. Interesting. Okay. So there's an issue with the helper function. So while start index less than equal to end index, I wonder if it's because interesting. I think this works. This should work. Let's go for a simpler example. Huh. This doesn't work. So even this simple example doesn't work. So let's see what's going on here. So start index is going to be 0. Again, we're looking at this case here. And the next can be 1. So while start index less than equals, that's fine. Mid index is going to be 0 plus 1 divided by 2. 1 divided by 2, which is going to come out to 0. And then if row at 0 is 1, which is not, because row at 0 is 0, start index is now going to become 0 plus, oh, wait, no, that's fine, that's fine. It's going to be 1. So that's great. Oh, I see it's happening. Because then as we go to the next iteration of the loop, end index is now going to be 1 plus 1 divided by 2, which is 1. But then row of mid index, row of 1 is 1. So end index is going to be reset to 1. Right? So then, then this is where we hit the loop. Okay, I see. Got it. So I think to avoid this, one thing we can probably do is make while start index less than end index. So I think, for purposes of video, we aren't talking about this binary search case specifically. We're talking about the leftmost case. And we've already went over the important part of using binary search to find the first current. So I'm going to kind of brush through this part, not go into too detailed explanation. But okay, this works here. Let's try the previous example, 0, 0, 1. This should output 3, right? Yeah, so let's see if this outputs 3. It does. Okay, and then what if we have 0? Just to kind of see. This should output, this outputs 3 again. So I think actually what we can do is we should add a part here. If row at start index is 1, is 0, then return -1, right? So as we saw here, this returns index 3, but index 3 is actually 0, right? And not 1. So, and we want to do some kind of check here. So this is a bit of an edge case here. So yeah, that works. So what if we do have 1? This should return 3. And just to be safe, what if we have all 1s here, right? Like, let's make this case here. This should return index 0. Makes sense. This should return index 1. Okay, great. Okay, yeah. So we had to kind of go through this bit of an edge case, even though it's not really an edge case. Pretty common case. And something I realized that we should probably rename this. Find first occurrence binary search. Let's name it of 1. I know the name is very long, but in production code, you don't want to make the name too unreadable or long, but we're LeetCoding, so it's not that big a deal. Okay, so, all right, so assuming we got this part is okie dokes. Let's copy and paste this into our helper function. So this is our improved helper function. Awesome. Now let's comment this out. Get rid of this, right? Put all our test cases back, put our code back, and then finally run it again. See if this is what we thought it was. So remember our helper function, we got to indent it. nest it inside the main function here. And then let's try this out. True, false, false. Okay, well, that makes it a little more complicated. Oh, we're not returning -1. Sorry, this is we're not returning -1 in here because remember we're returning length of. So sorry, apologize for that communication. So this part should work now. Remember we are inside a hump function that was returning -1, but as we discussed earlier, and I'm sorry I forgot about this, is that we actually want to return length of row if it's all 0. So mistake on my part. Let's try it in. Let's get it in. True, true, true. Awesome. Great. Okay, so after a little bit of hiccup, we were able to get this down. Okay, let's talk about real quickly the space and time complexity. So time complexity, again, you have to iterate through each row, right? And for each row, you are doing a binary search. So we are iterating through each row. So row times, for each row, what is the time complexity of checking that row? It will be log of C, right? Because there are C elements for each row, right? C columns. So that's great for time complexity, but for space complexity, if you look through the code, if you think back to the code, we're not actually, this is a benefit of binary search, we're not actually creating any extra space outside of any extra space that scales with the size of the input array. What I mean by that is we are creating extra space, but but that's not a function of how big the row is, right? Like we're not creating one element for each element and by row I mean matrix. It doesn't scale with the size of the matrix. So we're not creating elements like for each element in the matrix. We're not creating in variable, right? Like we're not creating a new matrix, right? We're just creating here like you can count 1, 2, blah blah whatever. Like let's say there's like 10 variables here. We're creating 10 variables, but even if the matrix becomes super huge, like 1 million elements, 1 billion elements theoretically, we would still have 10 variables created, right? So it does use extra space, but it doesn't scale with the size of the matrix. So because of that, we have a constant amount of space. So we have 0 of 1 space, right? Awesome. So yeah, that's basically this improved iteration of the problem using binary search. There is one final, most optimal approach to this question, which uses kind of like diagonal traversal. And some people, if you're a very visual person, you're clever, you might have noticed there's probably a way to traverse this diagonally. But this is also a pretty reasonable approach because using binary search, which cuts down on much time over the brute force solution. So yeah, hopefully this was helpful. And in another video, we'll go over like the most optimal solution. So drop any questions, feedback in the comment box below. And yeah, thanks for tuning in. We'll see you next time.